Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon, and welcome to yet another exciting INBIOSIS webinar lecture series. I am Dr. Kamalrul Azlan, the moderator for today's webinar. I hope the video has provided you with some backgrounds and information regarding INBIOSIS and UKM. So for those who are interested and keen to collaborate with us, you are most welcome to do so. Please feel free to check our INBIOSIS website and our social media for the latest update and info. I feel so grateful today that all of us are granted good health and can attend this webinar series. There will be many more webinars to come, and I hope all of you will join again in the future. So, INBIOSIS webinar series is established to provide a knowledge and research experience sharing platform to ensure we are still connected with each other and stay motivated in our research despite this pandemic. Before we further proceed into our webinar series, let me share a couple of housekeeping rules. So, lecture will take about 45 minutes, and Q&A session will take approximately 50 minutes and probably a bit longer depending on the number of questions received. Please submit questions in the Cisco WebEx chat box and FB Live page. I, as a moderator, will read the question during the Q&A sessions. And please stay tuned until the end of the session to record your attendance. So, without further ado, I would like to introduce our honorable speakers for today's, Dr. Nurkhalida Kamal, one of our research fellow at INBIOSIS. Before that, allow me to share with you Dr. Nurkhalida Kamal's CV. Dr. Nurkhalida Kamal completed her PhD in Pharmaceutical Sciences, Natural Product Chemistry and Metabolomics from the University of Starkly, Glasgow, UK in 2015 under the supervision of Dr. Angelia Edrada Ebel. PhD involved in the isolations of secondary metabolites from Malaysia medicinal plant using various chromatography techniques and also utilizing liquid chromatography, high-resolution mass spectrometer, and nuclear magnetic resonance-based metabolomics in endophytic fungi natural products research, including dereplication strategy, mining active compounds toward anti-trypanosomal activities, and also preliminary screening for optimizing medium-scale fermentation. She then worked as a postdoctoral fellow at the Starkly Institute of Pharmacy and Biomedical Sciences, focusing on metabolomics analysis of marine organisms, including seaweeds and marine microbes. She then joined INBIOSIS in 2020 as a research fellow. Research focused on the applications of metabolomics in natural products and food chemistry. She wants to understand the chemistry of various resources, why it is produced, and what we can use for it. She has vast experience in natural product isolation and elucidation from various organisms, including plants, microbes, marine organisms, and mushroom. Also familiar with NMR and LCMS and chemometric data analysis. The paper has won awards as Antamedica's most innovative paper in 2017, describing on the applications of metabolomics on natural product research. Let us welcome Dr. Nurkhalida Kamal to share her research finding.
Thank you very much, Dr. Kamalrul Azlan, for your very nice introduction. Assalamualaikum and very good afternoon. I would like to greet to the moderator and also to all the audience. And I would like also to thank to the director of INBIOSIS for giving me an opportunity to share my findings within this webinar series. So let me share with you my slide. So anyone can Can you see my slide, Dr. Azlan?
Yes, I can see your slide.
Okay. So basically today, I would like to share with you the application of dereplication and also metabolomics in fungal natural products. So the talk, I don't think will be up to 45 minutes, hopefully less than 30 minutes. So during my presentation, I will give you some of the introductions and definitions. And also I'll share with you also the workflow that I use in the metabolomic studies in fungal natural products. And also I will share you some of the examples that I use in these two strains, which is Laccio diplodia theobromine and also Pestalotheopsis olivacea. And the last one, I will give some of the summaries and sort of something that we can think about my research findings. So I just would like to tell you that this sharing session is actually part of my PhD study. Bear in mind, it was done between 2011 and 2014. It was about 7 to 10 years ago. So some of the lacking technologies or software that maybe limited the finding of this study will affect the results. And this is the title of my PhD study. I have actually two parts of my PhD studies. One, isolation compounds from the medicinal plants, which is Vitex pinnata. I also done some isolations of compounds from the endophytic fungal that isolated from these plants. So why I would like to study on fungal as the source of the natural product, because I did share with you some numbers. 100,000 of fungal species have been identified, so huge numbers. And out of that, the scientists expected that more about 1 million of fungal species will be identified. So this is such a huge sources of getting a very interesting and unique natural products. And also, we know that 300,000 of higher plants exist in this planet and having a unique endophyte within that plant itself. So it just to show you how fungal can be one of the prolific sources of finding a natural product. And one of the research finding that make this endophytic fungal such as a very good sources is when they found taxol from the Taxomyces, the endophytic fungal that they found in that willow trees that produce the taxol. So from there, they develop industrial production using this fungal species to produce taxol, which is more sustainable. However, if you work in the natural product isolation, you know the work is very time-consuming, laborious, need to use a lot of effort, hard work, and sometimes if you don't have any directions, in the end you will find the same compounds again and again. So in order to overcome that, basically in natural product isolation, the natural product chemists already implemented the replication step, which is they try to identify known compounds at the extract level so that they can eliminate that compounds in order to find a new compounds. All right. So this is just based on the objective to get a new chemical compounds. But then come metabolomics, not only in natural products, but also in other areas. And metabolomics in natural products, if we look at the workflow, it's embedded the dereplication analysis as part of the workflow in metabolomics. And metabolomics, as we know, it's a comprehensive qualitative or quantitative analysis of all metabolites present in the living system. So in my research study during my PhD, I used LCMS, high resolution LCMS, based metabolomics in the fungal research. However, there are also, other than LCMS, we also can use NMR, and both of these techniques have a pro and cons, which some of it having a limitation and advantage between each. So, ideally, if you can do it together, then it's better. But during my study, I choose to work on the LCMS. So I want to share with you why LCMS has been chosen as one of the instruments to study in metabolomics in natural products, due to the fact that this instrument having advancement technology, especially in terms of the ionization source and also the mass analyzer. For example, rather than just using the fragmentation, the ionization source used in high resolution mass spec normally is ionization mode, such as electron spray ionization, fast atom bombardment, chemical ionization, for example, and this is what we call soft ionization, meaning the ion will be ionized as M plus H or M minus H. And this make it easy for us to then come up with the molecular formula of the ion. And also, I would like to share also the mass analyzer that used in high throughput mass spec is, for example, quadruple, ion trap, QTOF. This is something that familiar for the metabolomics. And I use, for my PhD study, I use Orbitrap by Thermo Scientific. So I use Exactive machine. So the reason why we use this mass analyzer, because this is accurate mass analyzer, meaning it can the mass that the mass tolerance on this high resolution mass spec is between 0.0015 to 5 ppm, for example. So because this tolerance is very small, so that is why it's very accurate in terms of you want to identify the structure. For example, here, the TIC, total ion chromatogram for this peak at 15.25, for example, it shows you this molecular M over Z, all right? So from there, because it's very accurate, then that is why we can predict the molecular formula. And it's only two compounds that possible with this mass M over Z. And if we look closely to this pattern, mass spectrum, so actually we can see this is the isotope for this. Between these two, they are isotopes of each other. And this is actually is a chlorinated base compound type of isotopes, where you can see it's about 1/3 of the height of this earlier peak. All right. So that's why high resolution mass spec really give advantage for the in terms of natural product metabolomics, in terms of the prediction of the mass spec. So in terms in the fungal natural products, so what normally metabolomics will be used is there, for example, if you have like library of your fungal strain, maybe 100 strains of Aspergillus species, and you would like to know which strain that you should work on first out of 100. So you can use metabolomics to assist you in prioritizing which strain you should work on first based on the chemical novelty. And the second thing that you can use metabolomics, for example, if you have this specific strain that you want to work with, and then you would like to see optimize the condition for medium scale or larger scale fermentation. So you do the large scale fermentation first, and by changing the, for example, parameters such as the medium or maybe the pH, the temperature, sort of like that, so that you can link that chemistry data to the fermentation so that you can find what are the optimal conditions for you to grow in larger scale. The third one is to investigate the bioactivity. If you do the bioassay guided isolation, then you can use metabolomics as a assisting tool to navigate what are the type of compounds that you should focus on isolating. And the last one maybe you can integrate the metabolomics data with the various multi-omic data. So for example, if you want to confirm the expression of biosynthetic gene cluster, or even you want to investigate biosynthetic pathways, then you can add on the metabolomics or dereplication method in your study. So this is actually the metabolomics flow that I use during my PhD study. So if let's say I use it just to, for example, just to see what are the type of compounds in that species. So maybe I will just do the replication. If I would like to see to find the active secondary metabolites, then I can use both, and then to target what are the active secondary metabolites. So in a metabolomic flow during my PhD study, I will separate the positive and negative ionization. Basically, I will run both positive ionization and also negative ionization modes. And from there, I will I did data processing using NZMine 2.10. Now they already have 2.53 actually. So this is just to process the raw data. For example, the peak picking, deconvolution, deisotoping, and alignment. And from that data, the next step is the replication. This is actually an in-house macro Excel database that containing the commercial antimarine database. From this data, I will then transfer the data if I would like to study the multivariate data analysis in the SIMCA, depending on what I want to see. For example, I can use PCA, PLSDA, or PLSDA, for example. And in the end, I will find what, from this data, we'll find the target natural product and link it with the bioassay and see if that secondary metabolites is active based on the findings of these metabolomic studies. So during my PhD, I also use the MZMine not only for the processing the data, the MS data, but also as a visualizing mode. For example, to see the TIC for all the samples, all right? So different color giving different sample. Other than that, MZMine also you can do is you can ask the software to do a plot based on the mass. So for example, here this sample, you can see most of the sample is around M over Z 200 and 300 band, meaning the M over Z is about that. So it's more small molecule secondary metabolites. As you can see, towards the end, the larger compound will become decreased. So this is some visualization that can be used in MZMine. I think with the latest version more, more features that can be used. Other than that also, I use it as a scatter plot between two samples. So basically, the dot here represents to M over Z ratio that we call features. So this is features that can be found in sample A, and this is the features that can be found highly intensity in sample B, for example. So regarding the in-house macro database, so this database actually been developed by my supervisor. So all of the students and collaborators can use this database. So basically, this is just Excel macro where can easily dereplicate our sample based on the anti-marine database that embed in the macro. So what normally we did we just put our raw data that we process in MZMine in the negative raw for the negative mode ionization, positive mode ionization, and then we just click preparations, and we need then to remove the media effect. And the last one, we will just click the replication to see what are the features that can be correlate with the anti-marine database. So here I just show you, for example, here the dereplication result, the hits that we got is about 342. The unknown is 151. And this is just to show you such a huge amount of data that we gathered. And I still remember during that time, the automation is not there. So basically, when we get this data, we still need to search which compounds that suits the peak carefully based on maybe source of the compound. If let's say for this hit they have 1, 2, 3, 4, right? So if it's from bacteria or from lichen, maybe we can exclude it. But if it's from fungus, maybe this is something that we will take it. So this is something that during my PhD, this is the most time consuming because you need to work with a lot of data. So here I will share you with some of my findings that and also how I use metabolomics in terms assisting me when I do my natural product isolation for the fungal sample. The first one is with this sample, Laccio diplodia, theobromide. So basically, I would like to select what are the optimal conditions that I will use when I want to grow it in medium scale fermentations, which is around 20 liter. So normally in the lab scale fermentation, the standard method that we will use is we will have liquid culture using Wickham liquid media. And also we will have rest culture, this is for the solid state media. And also I will grow in 3 different times, duration of the time, 7 days, 15 days, 30 days for each medium. So out of that, when I send for the bioassay, it shows that only sample that cultured fungus that cultured in the rice culture for 30 days having active positive, anti-trinosome activities. So not only based on the bioassay results, so I would like also to see using the MZ9 tool how this mass spec features looks like, how it's the patterns. So for example, here is this one is for negative ionization A and B is for the positive ionization. And as we can see here, if we compare between 15 days and 77 days, most of the same compound, meaning they share most of the same ion features. in this between these two days, similar to the positive ionization. However, when we look at 30 days and 7 days or 30 days and 15 days, they share quite just not as many as uh, 15 and 7 days. So meaning here that 30 days produce different type of compounds that is not produced in 7 days and 15 days. So when I look in for in the proton NMR data, as we can see here, 7 days and 15 days dissolve in DMSO, meaning most of the compounds are polar types of compounds. However, when I try to dissolve in DMSO, some of the compounds cannot dissolve. But when I change to the chloroform, all the compounds can dissolve, meaning compounds that produce in 30 days mostly are semipolar, which is there are different type of compounds that produce in this specific day. So now we know that if we would like to work in natural product isolation research in microbes, either in fungi or bacteria, is good if we can have different source of medium, so different substrate, for example, and culture it in different days, which is represent to different developmental stage of that microbes, because they produce different type of compounds, and maybe that compounds that responsible for the bioactivity. So the second one, with the same species of fungus, I use metabolomics to investigate bioactivity. All right. So when I have the optimized condition, what I did was I cultured it in 20 liter, and then I extracted it. And typical natural product isolation, then I did the fractionations. So the first fractionation come out about actually 19 samples, and out of 19, you can see LT2 until LT8 are active against trypanosole, while the rest were inactive. So the question is there any similarities or compounds that can be found in these fractions that couldn't be found in the inactive fractions that can contribute to the bioactivities? So because we know that we have fractions that active and inactive, so what I did for the multivariate data analysis, I choose to do OPLSDA, meaning the supervised multivariate data analysis, by telling the SIMCA that, okay, these sets are active and there are sets that are not active. So can you show me the pattern of the features? So when I run the SIMCA OPLSDA, so for example, here, this is the S plot where I would like to see what actually compounds that contributing to the activity. So SIMCA will assist us in telling this is actually maybe the compounds that you should look into. And because I had the dereplication data that I run using the macro, so the peak that I checked, this is the list of compounds. We have 8 types of compounds. Some of it already isolated from the same species. However, when I did the chemical isolation, out of the 8 features that I should isolate, I only managed to isolate 6 and 8. And I also isolated the other compounds which is not in the table, all right, which is not predicted as active types of compounds. So the hypothesis that then I tell if the S plot giving me the right data, so I can can hypothesize that 6 and 8 will be active, while 9 is not active. So when I did my bioassay, so the result came that yes, that R-melin, the compound number 9, was not active, while compound 6 and 8 were active on anti-trypanosomal activity. So here, the take-home message is I successfully used Metabolomics as an assisting tool to navigate what are the active compound that I should isolate. And then when I check back at the S plot, yes, it actually showed that this is the desmethyl-lasiodiplodin, and this is cladospirone B. It's around that active site, while armalin is already in the middle where it lack of the bioactivity. And the last one, I would like to share with you how I use dereplication strategies when I work on this species, which is Pestalotiopsis olivaceae. So basically, Pestalotiopsis olivaceae doesn't have to actually any report on isolation of compounds from this species. All right. However, there are many isolation work that have been done in other Pestalotiopsis species. And when I look at the NMR data, for example, it's only giving you a similar spectrum for rice culture 7 days, rice culture 15 days, and rice culture 30 days. And it looks like that they only have 3 or 4 major compounds, which is not really right if you are working with the extracts. So meaning that NMR, because it's less sensitive, it only show you the major abundance compounds. And it's true enough that when I look at the liquid chromatography mass spec, at least I have about 21 peaks that I finally identified. And it's good actually to study to do dereplication studies on this species, because this species has never been done any isolation work. So the idea is, if this is from Pestalotiopsis, so maybe there are some of the compounds that have been isolated from previously from Pestalotiopsis have been produced by this species also. So based on the replication analysis that I did, 21 peaks have been identified. What I would like to share with you, most of it have been isolated from Pestalotiopsis species, and also Xylaria. All right, and the rest are from other fungi. Right? So this shows that how this macro dereplication strategy can be used in terms of, to see maybe the chemotaxonomic of the species. Again, out of these 21 peaks, that have been identified, for the isolation work, I only isolated 12, 11, 12, 16, and 17. All right. And other than that, there is one compound that haven't been picked in the mass spec, mass specs dereplication, which is compound 22, meaning that during that time, not all the compounds can be identified or ionized well in the mass. Maybe that is why this compound cannot be detected in the mass spectrum mass dereplication analysis. Because Pestalotiopsis a lot of chemical isolation and chemical work has been done on this pestalotiopsis. So some of the studies already came out with the putative biosynthetic pathway. So I wanted to see if there is any correlations between these interrelated compounds. So so this is the isolated compound, all right? I will skip this one. So based on these studies by Hughes and Snyder in 2011 and also Zhu et al. In 2014, both uh, findings propose a biosynthetic pathway on pestalotiopsis-derived compounds. For example, maldoxin, dichloromaldoxin, dichloroDihydromaldoxins, and also dihydromaldoxin. And what interesting that I would like to highlight here is for U.S. Snyder, they postulated that fission and flagellin involved in this biosynthesis. While for Zhu et al., they postulated that only fission that involved in the biosynthetic pathway of this compound. So meaning that this is the question that maybe biochemists can answer, or any scientist that work in biosynthetic pathway could answer, which actually compounds that involve, is it only fission or is it fission and flagellin that have been involved in this biosynthesis. And again, the compound that have been identified in the dereplication also have been proposed the biosynthetic pathway of pestaloxantone, maldoxone, and also pestaloether that I managed to identify during the replication analysis in the extract level. So perhaps what I would like to highlight here, the use of dereplication analysis, if any scientists would like to study in biosynthetic pathway. So as a summary, I have shown you how I use metabolomics to select the optimal process of the condition. I also share with you how I use metabolomics to investigate the bioactivity. And also I have shared with you how I did the replication analysis in the fungal natural products. So what I would like to share with you, if I can tell my younger version what should I do when I do my PhD during that time, 2011 and 2014. So what I can tell her, in order for you to study metabolomics in natural product, it is very important for you to design your experiment properly. Meaning here, you need to know what you want to achieve, because for natural product chemists, during that time, we only learn to isolate compounds, especially new compounds. But if you have objective, for example, I want to find the compound that gives the bioactivities. So I will design this experiment so that I will not miss any other steps, for example. And also because the limitation that I experienced was the small amount of extract or fractions that I need to work for the isolation of compound. So I should tell my younger version that I should cultivate higher volume rather than 20 liters. I should cultivate 40 liters of fungi so that I can get higher amount of extract, that enough to do for isolation, identifications, and also bioactivities. And also, if, let's say, I do my PhD study in year 2021, so what can I do differently? So I think currently MSMS experiment seems to be very important, especially for verification. So, for example, when I have this list of compound that putatively identified. However, I don't have the MSMS data to validate that this is the compound based on the fragmentation pattern. So I think that's the limitation. That's something that I should do now if I do my PhD in 2021. And based on this MSMS data also, I can then come up with the pattern networking, for example, molecular networking, where then it verified the compound, especially the new compounds that I would like to propose. And also, when I do, because fungal natural products, when you culture in different substrates or in different parameters, it will give you different expressions of compound or different type of compound that produced. So it would be very nice if I could add on the primary metabolomics, so metabolic pathway of that fermentation to see how, for example, all the sugar will take up what happened to the primary metabolites on different days, for example. And also maybe I can do a data fusions for metabolomics, NMR, and also mass spec. So for that, I end my sharing sessions, and thank you very much for listening. I'm happy to receive any questions.
Thank you, Dr. Khalida, for the very informative talk. Now, I would like to invite questions from the participants. Please submit and drop your questions in the Cisco WebEx chat box or on FB live page. I will read it out loud and hopefully Dr. Nurkhalida can answer the question. Now, we have a total of, I think, about 80 participants. About 60 participants from is actually viewing on this Cisco WebEx, and another 20 participant is actually doing this live on FB Live. So therefore, please submit and drop your questions so that Dr. Nurkhalida can answer any kind of question regarding the talk. So Dr. Khalida, as a start for this Q&A session, so you mentioned about dereplication step using in-house macro database. So my question is there any database available that can be used for you to do the dereplication step?
Thank you very much, Dr. Kamalrul Azlan. So for the question, so I try to rephrase your question. So you asked me, other than the database that I use, is there any available database that can be used, right? So basically,
Yes,
the database that I use is anti-marine. So it's a commercial database that you need to purchase. So meaning it's not open access. However, there are various platform or database that available. When what I read in one papers in 2020 about more than 120 database that related to natural products uh, are available. However, the one that open access is only about 50. However, what some of the databases are generic, maybe consist primary metabolite, secondary metabolite, so it's huge database. But if you work on the specific, source, for example, specific biological system, in my case, is on the fungi, the microbes. So I think in order, to just limit the source, the database, I will focus on any database that related to the intermarine. Of course, they also have For example, GNTS, HMDB, but it's different. And also Sign Finder, Mass Bank. So this is actually something that you can work on. For example, if you work on polyphenolic compounds, there are databases that compile all the phenolic types of compounds. So maybe if you work on that, you just tailor it with the database so that the data that you get is not so much for you to analyze.
Okay. Thank you, Dr. Khalida, for the answer. So we have several questions in the chat box. So I'll just read it out loud so that Dr. Khalida can answer it. Question from Dr. Imelda. Thank you very much for your sharing. May I know what solid state media can be used to culture endophytic fungus other than rice?
Alright, so for solid state fermentation, the one that I used was long grain rice. So it's actually the source of carbon. So of course you can use different source of carbon. For example, you can, for example, you can use. I tried to use oat. I tried to use what else? Different carbon sources. But if you ask me for if to do research, maybe something that we can think about is to use any byproduct waste, for example, from the palm oil industries or something that used to culture the mushrooms. These all from the byproduct waste to culture the fungus. And see how this fungus behave with by using different substrates. Yeah, definitely they have various type of solid state other than rice. Yeah.
Okay. Next question from FB Live, Hamida AB. So, hi, do you offer service for elucidating or isolating compound from fungus and determining bioactive? And another question from the same person, what kind of bioactive assay that you offer? Can you answer this, Dr. Nurkhalida? I think this question
Thank
is
you.
related.
From Hamida AB. All right, thank you very
Yeah,
much,
from
Hamida AB. So for this question, currently in INBIOSIS, we don't have the service for isolation or elucidating the works. However, in terms of collaborations, research collaboration, we are more than welcome to collaborate and to guide you on how to isolate and elucidate compound from fungus. And the second question, again, we still don't have any bioactivity assay that we offer in INBIOSIS. However, if you would like to do LCMS metabolomics or GCMS or IR, we have these facilities.
Okay, thank you, Dr. Nurkhalida. I hope that answered the question from Hamida AB. Again, if you want to know more about the service that offered by INBIOSIS, you can always go to our INBIOSIS website to look into what kind of service that we can offer to your needs. The next question from Dr. Hamiza. Thank you, Dr. Khalida, for your great presentation. Her question is, what are the difficulties that you were facing during the research study, in particularly on fungal natural product isolation?
All right. Thank you very much, Dr. Hamiza, for the question. So, for what the difficulties in terms of fungal natural products is the amounts that I need to work on in terms of the isolation is very small amount. And imagine that when you get your pure compounds at 1 to 2 milligrams, and you need to elucidate it, you need to if NMR is okay, it's non-destructive. However, if mass spec, you need to sacrifice 20 micrograms in 20 mil of the sample. So you will lose some activities. So the difficulty is the starting material sometimes cannot give you the amount of isolated compound that you need to do various types of analysis and bioassays. So that is why one of the my suggestion is, instead of grow it in 20 liters rice culture, I should work on higher, meaning 40 liters. I know the work is very hard, where you need to harvest the 40 liters of this, and then you need to dry it. However, it will be at least you feel secure when you do the isolation in the fungal isolation. Yes. So that's what I can share.
Okay. The next question from Bazli Abu Bakar. Thank you for sharing, Dr. Khalida. May I know, did you run your sample using HPLC first before proceeding to LCMS analysis?
Thank you very much, Dr. Bazli, for the question. So for that question, no, I didn't run any HPLC. Because when we did the LCMS, it already have this PDA analysis. So it's incorporate with this photodiode array, where you can see the how this spectrum looks like. So to answer that, no, we didn't do that. I just normally, when I get the extract or the fractions, I just prepare it for the mass spec and for the NMR analysis.
Okay. The next question from Dr. Tanjin Kit. Great sharing, Dr. Khalida, especially in using the Excel macro for metabolite identification developed by your supervisor. What approach do you use now to identify metabolites from the LC-MS data?
What approach do you already? So for now, because what I suggest is, rather than having LCMS data only, so if you have type of compounds that you need to work on, then it's good if you can run MS data. So I haven't done this yet, actually, Dr. Tan Jankit, but one of my collaborators, Dr. Ahmed, from UK, he is expert on molecular modeling. So with this MS data, without any isolation work to be done first, so he will try to connect this pattern and see what and then use the GNMPS database to see what actually type of compound that can be proposed from the molecular networking, and see again in the database if there are any related to this data. So to answer your question is the the metabolic networking is a good one if you have MS data to identify to verify the known compounds.
Okay. Next question from Akil Fitri. Thank you, Dr. Khalida. Great sharing. May I know, do you encounter any problems during dereplication, such as the targeted compounds are not detected? Would you share the contingency plan you did?
Thank you very much, Akil, for your questions. So the answer for that question, yes, I encountered that. When I did the replication, some of the targeted compounds that I know is there cannot be picked up. So basically, it's very crucial during the pre-processing that you cannot use a standard method for the pre-processing using the, for example, the one that I use MZMine. So I need to analyze during the deconvolation, during the peak picking, deisotoping. So I need to enter the certain parameters. So I need to play around with that parameters to ensure that these, you already know the targeted compounds. So it will be pick up because sometimes because it depends on the data itself. When you have this only one standard parameters that you always enter, sometimes the targeted compounds or the compound that should be identified couldn't be identified. Yes, of course, I accounted.
Okay, thank you, Dr. Khalida. I hope that's answer the questions by Akil. Another question by Dr. Hamiza. Could you list other examples of available software for pre-processing MS data?
Thank you very much, Dr. Hamiza. So for the questions, other than NZMine, for now is they have 2.53 if I'm not mistaken. That's the one that I use now. This is open software. So other than that, I think the pre-processing software that can be used to process the MS data, such as Metabolomics, Tidy MS. I think some of papers also been published on the pre-processing data. So up until now, I only know two, but I think there are more that available that you just need to search and see how feasible to use.
Okay, so if you have any question, please submit and drop your questions in the Cisco web chat. Okay. Just a quick question for me. So, how you determine the size sample for your experiment? Do you really need a large size sample to do LCMS and NMR?
Sorry, what do you mean by it? Is it the number of the sample?
Yes, the number of samples.
All right. Okay. Because when you do natural product isolation, basically, you will repeat fractionation and fractionations, several series of fractionation, and for us to run every time the metabolomics, for example, if dereplication you can have once, but if you would like to do metabolomics analysis, for example, uh, the normally for metabolomics they will have like 4, 5, or 6 sample on I mean set of each sample. However, because we do these uh, fractionation about 2, 3, or 4 times, so it's not in terms of money wise, it's not feasible. So instead of having large amounts of sample, we normally use on 2 or 3, it depends. Okay, but we will have like what we call standard that we can. It's not standard. It's standard that we can calibrate, meaning all of the sample that we run, we will mix it, and then we will see how the mass spec pick up. If from there we use that as a standard to see that the instrument can detect everything in the sample, even though by using 2 samples. So we put that in several, batch. Yeah.
So are you referring to pull sample as a QC to check whether the machine is okay or not? Oh, okay. Right.
Yes.
So we have another.
Yes.
Okay. So we have another question from Rafida Ahmad. Do you optimize the fungal extraction method, and how confident are you the identification of compound without MS? And do you run standard too?
All right. So for you have, I think 1, 2, 3 questions from Rafida. Thank you very much, Rafida, for the question. So I will answer one by one. So the first question you asked, did I optimize the fungal extraction method? So basically, I didn't optimize it, but we have this standard uh, extraction that been developed by my supervisors. So if I culture it in rice culture media, so I will extract it with ethyl acetate. So I will leave it for 24 hours. For the next step, then I will just extract. So however, if I culture it in the liquid media, so I need to do the partitions between the water as the media, and also I add the ethyl acetate. So from there, basically you will have actually two layers. So some of the compound, I think the more polar compound will be retained in the water, while for the small amount of small molecule compounds, that semi-polar will go to the ethyl acetate culture. So in my PhD study, because I really want to see the small molecule compounds, so I just target on the ethyl acetate extract. How confidence of your identified the compound without the MS. All right, so for this one, if that if the confidence level is if I run the dereplication and that compound has been picked up, and when I check it was isolated from the same species, I can say I'm highly confident because same species or same fungus normally share similar bioactive compounds. However, if it's from the animals or if, for example, I work in endophytic, and then the compounds that from the dereplication database suggested it's from the sponges or from the macroalgae. So this one I will not take up as a potential compound. But that is normally for the natural product chemist. When you get this dereplication method, the only way during my time, the only way I can verify it as a natural product chemist is to isolate it. So isolation is one way to verify it. However, uh, nowadays, I think if you submit your papers to the Q1 journal, they will require you to give the MS data for fragmentation pattern, so that to verify your dereplication analysis. All right. So do you run standard too? So for the method, yes, but not. I didn't run it. Actually, the technician will run it. They always put standard for the calibrations, and normally when he sees the standard, for the calibration is okay, then he can give us access to submit the sample, because we will operate our LCMS analysis by ourselves. But yes, there are standards to be run.
Okay, thank you, Dr. Nurkhalida. I think there are no more questions. So I think that's wrap up for our Q&A sessions. So we have actually come to the end of the webinar. So I would like to thank Dr. Nurkhalida Kamal from the very interesting subjects, and I'm sure this talk has actually opened our view and give the participant an idea on how you want to bring up your research output to the next level. So before we say goodbye, let us immortalize the session by switching on your camera and have our face capture. So I would like to ask all participants to switch on your camera for our photography sessions. So please open your camera. Now I will hand over to the technical team for the web session.
Okay, everyone ready? Right. Okay. 1, 2, 3. Okay, one more. Okay, one more. 1, 2, 3. Okay, thank you.
Okay. So with that, as a reminder, a QR code to access link for attendance registration, which will be shown those who want to record the attendance. So the code is available for 50 minutes only. With that, I would like to thank to all participants for spending your time with us today. Please stay safe and very good care of yourself. With that, thank you.
Thank you. Bye-bye.